Okay, and welcome to 4.4. We're going to be covering hyperbolas in this section. We already covered the other conic sections of parabolas, ellipses, and circles earlier in class. So this lesson is just going to cover, this video is just going to cover hyperbolas. Okay, so hyperbolas, you guys could write down these notes. This is what a hyperbola is by definition. It might seem a little confusing, so if it is, you don't have to write it down. We are going to talk about what a transverse axis is and looking at the center. The midpoint of the transverse axis is the center of the hyperbola. And the transverse axis is a segment that lies on the line containing the foci and the endpoints. The endpoints for a hyperbola are going to be the vertices of a hyperbola. So we'll see that it could be, we went over this a little bit, this can be the shape of a hyperbola, kind of like the Hurley symbol, or this can be what a hyperbola looks like. Okay? And by definition, if we picked a point and we found from that point to foci 1, so we're going to have two foci, and if we had a point and we added this distance plus this distance, or sorry, subtracting that distance, if we took this distance here minus this distance, and we took the absolute value of it, then we would get a constant k. Same with here, we would have the foci. If we find any point here, we take this distance minus this distance, we'll get a constant after we take the absolute value. Okay, so let's take a look here. The standard form of a hyperbola, you want to write this equation down. You guys will probably want to pause the video to get everything in here. Notice that we know that in an ellipse, A is always bigger than B. That is not the case for hyperbolas. Okay, A squared and B squared are going to stay where they are. What changes is what is positive. See how it's a minus here for hyperbolas? So when we're looking at if it's a hyperbola or not, the thing that is the main part is the minus. So in this part, we have y squared is first. That's your positive part, minus your x squared over b squared. And it's still equal to 1. So if it is not equal to 1, then we would make it equal to 1. Okay? So let's take a look at what we have here. So here, we're looking at the foci. The foci will be F1 and F2. And if I kind of sketch this out, sorry, I'm going to apologize if my graph comes out a little ugly here, but it's going to be, we're going to start here, and this is going to be one of the branches. That's starting out pretty good. And this will be, then coming down here, this will be one part, and this will be the other part. It should not cross that asymptote here. Okay, so let's take a look at what we have. So notice your y squared is first and it is positive. If y squared is first, that means it's going in the y direction, meaning up and down. Your two branches are up and down, okay? So just to highlight that, maybe I should make it a little bit bigger here. This is going to be going up and down, the two branches. So from here, wow, that's a little too thick, but that's okay. And here, it kind of covers my terrible graph now. Okay, so, wow, that's a little ridiculous. That's okay. Okay, so these are my two branches, and let's take a look what we have. The vertices are going to be 0A, and if you look here underneath your y, you have A. All right, so underneath that, you'll have whatever your A is. This is A, and this will be negative A. Those are your vertices. Then notice here from your center to your vertex, this is A, right? A. And then it does matter what the value of B is, because what you're going to do when you graph these is you're going to draw something called the central rectangle. In the central rectangle, we're going to go up A units, and we're going to go over B units. So from here to here is A, and from here to here is B. This is going to be called the central rectangle, and then I'm going to actually draw in my asymptotes, here are my asymptotes, by actually looking at the diagonals of your central rectangle. Okay, so here are the diagonals of my central rectangle here, and these are going to be my asymptotes. So when you're finding your asymptotes, you're just rising A and you're running B. Just like your slope, rise over run, right? We rise A, we run B. A over BX. This is the positive, this is the negative, right? We rise A, we run B, but in the negative direction. Then you're going to just follow, your branches will just follow your asymptotes, okay? Here's the transverse axis. That transverse axis has endpoints at your vertices. In this case, it's A. Okay, let's take a look at the other way. So now we can see that the difference here is that now we see that your x squared is first and is positive, and then your y squared is the negative part. So see here how it's going to actually be still a minus, which is what makes it a hyperbola. Okay, it's still minus there. And we'll go with something that's not as thick as the previous line. And there we go. Okay. So if we look here, now it's going to be going in the x direction. So to graph this, I'm going to start with my vertices. See how here your A is now underneath your X. So A is here, and I'm going to follow my asymptotes to sketch the graph. And then same with this here, following my asymptotes to sketch the graph. Beautiful. Okay. So now if we take a look at what we have, the value of A is underneath X. So from here to here is A now. A is now with your X direction, and your vertices are A0 and negative A0. The B is underneath Y. So to draw the central rectangle, B is going in the Y direction. So now if we take a look here and we draw in our asymptotes, now we're rising B and running A. That's why now your asymptotes, or the diagonals of your central rectangle, are now B over AX and negative B over AX, because you rise B and you run A amount. That's how we got these two equations for the asymptotes. Okay? Here we have no y-intercept. Okay, so let's try one. So, actually we first have to go over the foci. So the foci, just like when we found an ellipse, we use the Pythagorean theorem. This is how we find the foci when it is a hyperbola. So we're still using the value of C there. So the distance between the foci to C is also the length of the diagonal of the central rectangle. So they're saying this whole diagonal from here to here is 2C. So this is going to be C. Okay, so it doesn't actually matter if this is a vertical or a horizontal one. We'd still have A, B, and then C, and that would give us a right triangle. And therefore, you can use A squared plus B squared equals C squared right here. Okay, so let's try one out. Here we go, finding the foci and draw the graph. So if we start out, it's y squared over 4. When your y squared is a positive one, you know that it's going to be a hyperbola that will be in the y direction, meaning up and down. So we'll first draw in our central rectangle. We know a squared is 4. We know b squared is 9. So therefore a is 2 and b is 3. Okay, so we're going to go up 2 in the y direction and down 2 in the y direction. These are going to be your vertices. So I have 0, 2, and I have 0, negative 2. Then I'm going to go 3 units to the left and 3 units to the right. 1, 2, 3 units to the right. 1, 2, 3 units to the left for both of them. And those are going to be my corners of the central rectangle. So I'm going to just draw in my central rectangle here. Here it is. And this is going to help me with finding my asymptotes. Okay, so now actually finding your asymptotes, we just take the diagonals of the central rectangle. So this is going to be rise 2 and run 3. Rise 2, run 3. 1, 2, 3. Rise 2, run 3. Okay, so starting from here, and this is what the diagonal or your asymptote will look like here. And then rise 2, run 3, 1, 2, 3. Rise 2, run 3, 1, 2, 3. Okay, and then it will go through like this. Okay, so now we can use that to sketch our graph. And when we actually sketch our graph here, then we can see, okay, I'm going to be using from this point here, and then I'm sketching it using my asymptotes. And I knew that it was going up and down because my y value is first and is positive, and down like this. You should also make sure that you write in what the asymptotes are. So your asymptotes here are we rise 2 and we run 3. 2 over 3x. Here we rise 2 and we run negative 3. So this is negative 2/3 x. Those are your asymptotes. And then finally we can find the foci by using a squared plus b squared is equal to c squared. So we know that a squared is 4. B squared is 9, and that's a total of 13. So since we have c squared is equal to 13, we could take the square root here and therefore get c to be about, what is that, 3.6. Okay, and then so from the center to the foci is 3.6 units away. So about right here, this is 0, 3.6. And from here down, so right here is 0, negative 3.6. So your foci are going to be 0 plus or minus 3.6. Okay? All right, moving on. Here we go. We have to write an equation for a hyperbola centered at the origin with the given characteristics. So horizontal transverse axis. So if it's horizontal, you know it's going like this. Okay? So that means the horizontal transverse axis, A is from the center to your vertex. So this is going to be 11. And then we know from the center to, there we go, something like that, to the foci is 15. Okay, so now we can actually use a squared plus b squared equals c squared to find what b is. Since it's a horizontal transverse axis, then we know x squared is first, so we go x squared over a squared minus y squared over b squared equals 1. Okay, so we know a is 11, so 11 squared is 121. We're finding what b is, and we know c is 15, so we go c squared is 225. Okay, so we can subtract 225 minus 121 and get 104. So b squared equals 104. And some of you might be saying, okay, when I take the square root, it's a decimal, but actually we only need b squared. So to write this equation, we would get x squared over a squared, which is 121, minus y squared over b squared, which we just found, 104, is equal to 1. Okay, and let's try maybe one more. The vertices are plus or minus 4, so if we actually drew this out, plus or minus 4 is 0, so this would be 4, 1, 2, 3, 4, and negative 4, right? So again, it's horizontal, so we're using x squared over a squared minus y squared over b squared is equal to 1. We know the perimeter is 28. We also know perimeter is equal to 2L plus 2W. And we know that if I was going to draw this in, well, from here to here is a total of 8, right? So if I say my width here is not just 4, because from here to here is 4, but it's a total of 8. So I'm going to say my width is going to be 8. And now I can find what L is. Okay? My perimeter is 28. So finding what that would be, I have 28 is equal to 2L plus 16. I can subtract 16 from both sides and get 12. So I have 2L is equal to 12. Therefore, L is 6. So the entire length is 6, right? So this was A. A was 4. And now I can say my B is half of the length. So therefore, B is 3. Okay, so this is 3. So if I actually drew this in, here, from here to here is 4, right? From here to here is 3, and then we can check it. So the whole thing is 8. This whole thing is 6. 8 times 2 is 16. 6 times 2 is 12, and 16 plus 12 is 28. So that works. Okay. So now I know B is 3, I know A is 4, so we have x squared over A squared, or 4 squared is 16, minus, I have y squared over 3 squared is 9 is equal to 1. We're going to do some more problems like these tomorrow, and we're going to do translations of all of them. So try your best on this, and we'll see how it goes. Thanks for listening, and I hope you learned some. Bye-bye.